Ever seen those cool, trippy animated battle backgrounds in old school games like EarthBound and thought, how on earth did they make that? Today we're going to break down another trick from the retro graphics playbook, Vertical Oscillation, and we're going to see how we can implement this technique using WebGL. If you saw our video on horizontal oscillation, the concept here is exactly the same, just flipped on its side. We're going to take an image and push its pixels up and down using a sine wave. So if we take our original texture and we apply our sine wave to it, and we use that as a guide for moving our pixels, but this time, instead of having our sine wave go this way, we want to turn it so it's horizontal across our image. So when we do this, our white line here, this represents the position of our original pixel. For our sine wave, we're going to move our pixels so they line up with our blue sine wave here. When our wave is at our peak, we're going to take all of our pixels in that column and then shift them up. When our wave's at the throw, we're going to push all of our pixels in that column down. And then when we're in the middle, we're not going to move those pixels at all. So this is very similar to a horizontal oscillation, just the two main differences are, instead of shifting our pixels by row, we're going to shift them by column. And then for our sine wave, instead of having this going up and down, we're going to have to be horizontal across our texture. When we do this for every column of our pixels, we get this cool wavy distortion. To make it move, we do the same trick as before. We make the sine wave itself move by tying it to a time variable. As the wave glides across our image, the pixel distortion follows it, creating a smooth, bobbing animation. And just like before, we can control our amplitude to change how high the waves are, and the frequency to change how many waves appear on our screen. So in this video, we won't be doing a deep dive into the sine function and how it works, but if you are interested in learning more, we cover this topic in depth in our video on horizontal oscillation. There'll be a link on your screen now, as well as the description down below if you want to learn more. Alright, let's build this in WebGL. We'll need our image texture that we want to distort, a time uniform to animate our sine wave, and a couple of parameters to control our amplitude and our frequency. Currently, my code is set up to read in a texture and just render out the original pixels. So in the example here, I have 4 different textures. If we want to render out a different one, I just need to modify the index in my textures array here. So now to create our effect, first we'll create our variables for our speed, our amplitude, and our frequency. So we're going to do our float, we're going to do a U speed, we're going to set that equal to 2. Now we'll do our amplitude. So we're going to do 0.05, and now we want to do our frequency. I'll set that to 20. So our amplitude and our frequency, this is going to control what our sine wave is going to look like. Now we need to calculate our position for our sine wave. So let's do float. We're going to call this wave. We're going to set it equal to our sine function. And now we need to use the x position of our pixel that we're currently processing. So this is going to be my UVX. We want to multiply this by my frequency. And now we need to calculate how far we need to move our pixel. So this will be our offset. We'll set that equal to our wave float, and we're going to multiply it by our amplitude. And now we need to calculate our new coordinate based on this offset. So we're going to do a vector 2. We're going to call this new chords. We're going to set equal to a vector 2. Now for our vector 2, since we only want to shift our pixels in our column, we want to keep our original x value. So we're going to do our UVX. And for our y value, we're going to take our original value, and we want to add in our offset value. With our new coordinate, we now need to look up our pixel from our texture that we're going to render out. So let's do our out color. We're going to set this equal to our texture. And now we need to specify our sampler we want to get our texture from. So we'll do our U textures. We'll grab our first element in our array. And now we need to specify our coordinate that we want to sample from. So this will be our new coordinate. And now our out color, this is our vector 4 that we're going to render out. With that, we now have this wavy distorted effect being applied to our image. So now if we want our effect to be animated, we just need to update our value that we're passing to our sine function. For this, we just need to add in some type of offset, so then that way it's constantly moving. For this offset, we're going to add in our time for our offset. We're going to add in the amount of time that has passed since our shader was compiled. For this example here, I have this U time uniform. And once we add in that offset, we now have this nice smooth animation. And now if we want to modify how fast that wavy effect is, we can multiply our time uniform by our speed. And then once we do that, all we need to do is modify our speed value, and this will control how fast that animation will look. So here's what's happening. For each pixel, we calculate a sine wave value based on its horizontal position plus the elapsed time. That sine value determines how far to shift our pixel vertically. We then sample our original image at the shifted coordinate, which will produce this wavy effect. Because this runs entirely on the GPU, it's super efficient, perfect for games, demos, or any scene that needs some subtle organic motion. And that's the vertical oscillation shader in WebGL, a simple idea with beautiful results. In the next video, we'll plug this shader into Phaser 3 and make it game ready. Thanks for watching. If you found this helpful, please give it a thumbs up and drop a comment with any shader effects you want to see next. And if you want to support the channel and help me keep making tutorials, I've set up a Ko-fi page. The link's in the description. Every coffee helps. Don't forget to subscribe so you don't miss the rest of the shader series and more Phaser tutorials. See you next time.